All right. Hello, everyone. So another live stream on incus-os. Actually, let me just change the setting here on my side so my microphone doesn't block my display. Here we go. Cool. All right. So where are we at, and what happened over the past week before looking at what to work on next? So, and last little bit of a recap. So, the pull request I pushed last week during the stream was around that. Yeah, there we go. So, oh, I made a typo here. Okay, so in last week's stream, the goal was to make use of the new seed partition. So that's a partition in the incus-os base image that we can write a tarball to, and now we've got a Go package that can extract specific files from that. And in this case, it was about extracting the application list. And that application list then kind of overrides the default, which would be to just install Incus. Now you can choose to install Incus and the debug package and have the daemon pick that up and do it. So that's where we wrapped up last week. Then I did a bunch of things following that. So over, I think over the next day and a bit over the weekend too. So some of the stuff I did was cleaning up the process list, both adding things that were missing. So for example, for LVM, we're missing the sandlock package. So I did that. I noticed that the debug package didn't have ping, so I did that. As we're adding more networking features to the base image, it makes sense that it can advertise itself to switches and have switches notify it about what port the machine is connected to. So we've got LLDPD now that's installed by default for that. Followed by, in this case, we're switching from daily builds of Incus over to stable builds because we don't really need anything from daily, so could just switch that, that's fine. Removing the BurrowFS tools because the base image doesn't do anything with BurrowFS, so there was no need to have those there. And they're being pulled by Incus anyways, so then the Incus application pulls that in. Then a bit of interesting reshuffling and logic. I can actually show you that one to get ZFS included. So getting ZFS in the image was a bit of work. The end result is pretty short actually. But basically what I needed to do was first make sure that the kernel build we're using, so that's the kernel I build through Zably, supports pulling the UEFI platform keyring keys into the OS module signing keyring. That's needed to then be able to sign the ZFS and SPL kernel modules with the same key that signs the image and effectively allow the kernel to load those modules. So that took me probably an hour to figure out exactly the right code, but it ended up being that script that just effectively allows the modules to be installed, but just in a build environment, because we don't want to end up with compilers and DKMS and all of those packages installed in the base image. We just need them at build time. So in the build environment, it installs a compiler, it installs what it needs to build kernel modules, and then it installs OpenZFS, ZFS DKMS, which is the actual source code for the module. That triggers a build against the kernel image. And then after that, we've got a build script that runs right after, which uses the signing keys from makeOSI to sign the kernel modules and write them into the destination image. So the result is that the destination image is still quite small because it doesn't include any of the build tools. It just includes the two kernel modules signed, and it includes the OpenZFS tools. So that was for the ZFS part. So now we have that in the base image. Next was doing a few more tweaks. So ZRAM generator, it was used until we had a swap partition. Now we've got one by default, so no need for that, so that went away. Kernel headers, We don't need those, and they're huge. So I changed the packaging of the Xabli kernel so that we've got a new kernel package called Linux image Xabli, and that package does not include the kernel headers. So that's now a good way to just pull only the binaries. And obviously when building ZFS, we do need the headers, so we install a normal package during that stage, but that saves us a whole bunch of space on disk in the resulting image. Then LLDP didn't want to work because it was missing a user, so just adding a file to add that user, and then added OpenVSwitch to the base image. So that's just so we can eventually add the oven controller as well to be able to include those like an incus-OS system into an oven cluster being driven by an oven cluster anyways. So OpenVSwitch is now installed. That didn't grow the image by much because I had tweaked my own builds of OpenVSwitch to not needlessly pull Python. So that's pretty lightweight. And after OpenVSwitch, I did a bit of work to try and shrink the image as much as possible. So that's actually taking a bunch of cuts and literally wiping out entire folders. So we don't need documentation, we don't need man pages. As a reminder, nobody is supposed to ever have a shell on that machine, so there's really no point in any of that stuff being around. And also removing some kernel modules that are not needed because they're just like for desktop systems or for other systems or for the kind of devices that we're not actually using with incus-OS. So that's that. And then what was the fixed symlinks one? Oh yeah, OpenVSwitch wasn't starting because on Debian systems you have a bunch of files including binaries. In this case, awk, which, and obviously switchd itself, that are a symlink to a file in /etc alternatives, which then links back to the actual binary that needs to be run. Because our image does not have /etc and it only has /user, that doesn't work. So I effectively put a bit of logic to override those symlinks and kind of recreate them back as the correct target, and that fixes the issue. So that was needed. Then disabling a bunch of services and units. So basically took a look at what's running out of the box when you boot up the system and turn just about everything off. That includes turning off LLDPD. And the reason is that we don't always want it to run. We want it to run in some environments. So it's better to actually have systemd on first boot disable all of the services. And then incus-OS, the incus-OS daemon will be able to start them back, enable them again if needed. And some of those just don't make sense to keep around, like the sys update, reboot timer, all that kind of stuff. We're not really using any of that. We drive sys update directly. The dpackage db backup, the system is read-only. There's nothing to back up. There's also no dpackage database anyways. So just kind of cleaning that stuff up so the systems doesn't try to do pointless actions, basically. Then that was just bumping the timeout of the GitHub action because of adding ZFS really increased the build time. So there's that now. And changing the way OS update testing is done to go through effectively just, I think the normal steps from the makefile. I think at this point, I think we're just using make test. No, we're just pushing the correct release. incus-osd was not exiting after an OS update, so that's been fixed too. And that's mostly where we are. Now there are a couple of PRs open. This one I didn't merge yet, I'm not sure why. I should actually merge it. It's adding a bit of logging, and then for both incus and kernel, and now for OpenVSwitch and oven, there are tricksy builds of all of those in Xabli repositories, so we don't need to cheat and use Ubuntu Noble, I think is what we're using, to have something compatible with tricksy. Now that's been fixed, so this one can get merged. It's passed all the tests anyways. And then we've got another PR that's currently being worked on, but which adds the network generation side of things. So effectively taking a structured network config and turning that into the systemd network configuration files. You can actually take a look if you look at the issue for what the config kind of looks like. I've put in a few examples of how we want to handle bridges and bonds and that kind of stuff directly in incus-OS. It's very similar to a net plan syntax, but not quite all the way as far as all the features the net plan supports, but also going deeper in some features that net plan doesn't care about. So for example, we're gonna put the LLDP stuff in there. We're gonna be, we've got already better support for like VLAN tagging and bridge VLAN filtering, those kind of features, which I've not made it into net plan. We've got those in there. And most importantly, we can't really use net plan because it would pull Python and a whole bunch of other stuff, and we want to keep the image really, really small. So that's basically where we're at. Now, for this stream, the goal is to basically two things. One is making the Incus, put it in the right folder, IncusOS, there. Okay, let me just update that repo now. Okay. Here we go. Okay, so the goal is incus-osd is currently built and is currently included in the images, which is fine, but it doesn't actually start up on boot, and it's not a daemon yet. So kind of need to do both. The first stage is going to be just turn it into a daemon, which is basically as simple as making it not exit at the end. Probably going to do it slightly smarter by actually having it bind, like open a Unix socket, like run incus-OS Unix socket or something along those lines, and then put a basic HTTP listener on there and not implement any route or anything at this point, but that's going to be kind of the beginning of being able to provide a REST API on this thing. Once that's done, then running the command will just run its initial actions for what it does on first start, but then it's not going to exit or anything. It will just stay, like, just keep running. Once we've got that, then need to make sure it ends up in the image, which it should already. And then basically systemd, put a systemd unit in place so that it starts up on boot. And after that, it's going to be a bunch of makefile and stuff updating so that we don't run it manually anymore. We just start the image, know that the daemon is there, let it do its thing. But that's basically the idea. The first thing I wanted to check is, as it stands, so if we look at, I think it's images base, makeosi, extra, user, local bin. Yeah, so new images are supposed to include incus-osd. I've not actually seen that work yet, so I wanted to make sure that it does. So if I go into test incus-OS, that should be one of the newer ones. Yeah, it's got the ZFS tools, so it should be recent enough. Does it have, it does have incus-osd in there. Okay, so that piece worked already. That's all good. One thing is, I think the binary could be made smaller, so let me check. If I look at incus-osd here, 9.7 megs. If I strip it, 6.6. Yeah, so that's good. Let's just tweak the makefile a bit to do that. So we actually do build incus-osd right here. Let's see if we build it anywhere else, do we? No. Excellent. So if we don't, let's just change that chunk a tiny bit. Actually want to make a separate target. That's going to be cleaner, I think. So for me, incus-osd, osd, and then, so we'll make it, the first one is just building, and then the second one will be stripping, stripping the binary. So when we do that, cd, okay, so it's going to build as incus-osd incus-osd. Okay, let's see. So I should be able to do make incus-osd, builds and strips it. Good. All right. So let's just change that. Make file strip incus-osd. There we go. Cool. So as it stands, binary makes it into the base image, and now we've got it to be slightly smaller. So that's great. Good first start. Next is, as I said, this current binary, it just runs and exits, and that's what it does. So we need to change that. If we look at incus-osd and push that to test incus-os, so push it into the VM down there, and I run incus-osd. Okay. It does its first boot things, it's already up to date, and then it exits. So let's make it not exit anymore. Now, that's going to be in the main package. I think we're going to be doing that for now. Currently, there's a run function that does a ton of stuff. We're going to be basically renaming that, like a lot of that, as into a startup function that then runs immediately on daemon start, but is separate from the run function itself. I think we can probably split it right around this spot here. So just call it startup for now. So error, and startup takes context. And that's basically just a prelude to splitting this further into more and more functions. You might remember from previous live streams, whenever I run Golang CI, it complains about the complexity of the run function at a time. Now it's going to be the startup function, because it is kind of too complex. It needs to be split into smaller chunks and be called and stuff, but not there yet. Also, the that crazy condition thing here is still there from last week. That still needs to get sorted into something much shorter. Anyways, so that's the startup function. Now we've got run. Here we want setup listener, and then run startup tasks, basically. Okay, so just checking the storage paths and stuff, but we've got var path here. I think we're gonna do another one for run path, run incus-os, and do basically the same logic where we're gonna be creating it if missing. Yeah, come on, seriously. Okay. So creating the runtime path if it's missing. And then, so permissions US 700 on the folder seems fine. Basically, let's run path instead of var path. There we go. And after that, we set up a listener in there. So it's something we've done in a bunch of places lately with like migration manager and whatnot. So I can probably go just look at the migration manager code base instead. That will save me a tiny bit of time. Unix socket, there we go. And just checking what's actually defined. Okay, looks like it's true a variable, and then it ends up in this package. Okay. Let's authenticate, not what we want. This guy, so REST server daemon. And it's kind of too abstracted because it does a bunch of stuff for authentication and whatnot. But yeah, the bulk of it is this, getting a listener with netlisten Unix on the path we want. We just need to make sure that the socket is gone before we do that. It's not always the right thing to do because you might, you might run into issues where if you're using socket activation, for example, you don't want to always wipe the socket, but in our case, we are not gonna do socket activation on this daemon, so we can just always delete it effectively. So to to set up the listener, we'll do ignore output of OS remove, file path join. Actually, we can do listener path is file path join of run path Unix socket. Okay. And then we just want to remove listener path in case it already exists. And after that, we can do listener next listen Unix and then listener path. Okay, so that will just set up a basic listener. At this point, there's nothing actually running on it, but that gets us the listener. And then we need to actually do effectively an HTTP serve on the listener, which is then the blocking action. Let me just check the easiest way to do that. I think it's basically there's a serve, like basically serve forever type function. Yeah, serve takes the listener and a handler. So we don't currently have a handler, but we'll need to just define one, and we don't need anything particularly fancy as far as the handler. We can literally return. Yeah, we could just return not found for anything right now. That would probably be fine. Okay. So at this point, we've got the listener. We can probably do the startup tasks. So just do and so get it. We can run startup at this stage. Which may just immediately reboot the machine, but that's fine. I just wanted to check, is anything called OS exit? No. Which is actually weird. There should be a call. Yeah, this is wrong. Okay. Anyway, that's a separate fix, but okay, so we've got OS exit now. Startup tasks are being run right here. And then we basically return http.serve on the listener. And that's where we can pass an existing handler from the HTTP package for now, so just not. Okay, something along those lines. Make incus-osd actually would be better. Declared not used context. Where? Okay, it's declared. I thought I used it. Oh, it's because I forgot to pass it to startup. That's why. Okay. Okay, that's fixed. Line 44. Yep. That's the first definition of error. There we go. Then we're missing for net and HTTP. Okay, so just missing imports. So we want net and we want net HTTP. Okay, unexpected name. Okay, so there's just a messed up line here. Okay, cannot use not found handler. It's a function that returns a handler as a handler. Okay, so we actually just need to call that. Yep, there we go. So now we have a daemon. Let's test that. Yep. So it does the exact same thing, and now it hangs because it's just waiting to run. Now let's see. Incus test incus s. Oops, exec. Okay. All right. So did I put the debug package? I did not. Okay. So I need to actually do the provisioning for the debug package. I don't remember if I've got a YAML handy. Still, I don't. And it's not YAML, it's JSON, I think we've done in the end. Anyway, so I need an applications JSON. Let's do applications as a list. Or was it a map? Huh. don't actually remember what I did last week, Kelly. Let me check that one real quick. That was in incus-osd, internal seed, applications. Okay, so the type is a list of application, yes, and then each application just has a name. Okay, cool. So that's correct. And then in here, an application is basically just name. So we want Incus, and we actually do want debug. Not too sure why it's mad about that now. Okay, that's fine. Just rechecking. Yep, all good. So that should be a valid JSON. Now, seed.tar and the applications. Okay. And I'm just gonna push the seed file into the instance. That actually won't be possible at some point because it's supposed to be seed data, so just first boot. Right now, there's no actual check for whether we're doing it on first boot or not. But still, so dev mapper, not dev mapper, dev disk by path label, seed data. Okay, let's rerun that. Downloading system extensions, debug, and now we should have the debug stuff in place. Yep, which includes curl. So I wanted curl to be installed because curl supports doing this. You can do Unix socket and then pass a path to a Unix socket. In this case, a Unix socket, and then you can poke whatever you want. So say OS 1.0 returns page not found. Okay, so that confirms the handler and everything works exactly as expected. We've got a daemon listening. We actually started it twice, so we could confirm that the removal of the old socket works correctly. So that's all good, and it keeps running. It's behaving the way we're expecting it to. So now let's just go run some static analysis and make things happy on that front, then commit the changes, and then look at the next thing on there. Okay, so a few things need tweaking. Go show. Okay, because the main it's complaining about line 101. What's on there? An HTTP serve that has no support for setting timeouts. Okay. Which one of it would we rather me be using? Just checking the other serve stuff. Okay. Whatever was that? G114 on GoSec. What does it want me to do instead? Trying to see what you're supposed to be doing to fix that stuff. Okay, create an HTTP server with a read timeout, write timeout, and then do listen and serve. Okay, sure. Let's go ahead and do that then. So instead of just calling serve, the idea is to actually set up a full server. So let's do setup server, and we'll define the server as an HTTP server with so it would do the other field is apparently the listener, maybe. Let's try that. And then read timeout. Just put some basic read write timeout, I guess.
for the time being. And then on that, we can do server dot what is it, listen and serve. Oh, but it doesn't, where's the handler then? Let me check what the server struct looks like. Server struct, there we go. Okay, the handler is another field, it's fine, so. And the other is supposed to be a string, so that's not what we want. Anyway, handler is http.not handler, so that's fine. How do we pass it? The actual thing we want. Let me just check. So, because I need to pass it an actual listener. Let me check how they've actually implemented the default serve endpoint and just replicate that, I guess. Serve, how is serve implemented? Serve is a server with just the handler being passed, and then oh, okay, the serve, right, listen and serve is wrong, we just want serve, and then you do serve and you pass the listener. That's how you do it. Okay, in this case there's no address because there's nothing to listen on. There we go. Okay, so that should do it. I'm in the wrong folder now. Okay, so just complains about time not being imported, but otherwise that's fine. So I actually wanted to do a static analysis entry in the makefile as well. So let's do this real quick. Static analysis. So I can just have it do the Golang CI lint run in there. There we go. Let's see what we're left with at this point. So, file is not properly formatted. Well, okay, that's easy. There, sure. Okay, try that again. Cool. Function startup should pass the context parameter context check. Okay, I think we do. Let's see. So yeah, I'm not sure why this one is using background actually. Okay, incus-osd main. Yeah, so its point is that we already have a context. Instead of using background, we should use the context, which is not wrong in this situation since, yeah, this particular function is not called from a daemon. Should probably do that. So, you're happy now? Yay. Okay. Oops. I keep forgetting that make builds the entire image. I'm sure you want that, but just usually want to make incus-osd. So that's all good. Now let's turn that into some commits. Yeah, I can do the makefile real quick. So makefile is just makefile and static analysis target. Okay, what else do we have? All the changes in there. So okay, that defines the run path, that adds, so the exit one should be add its own thing. Exit non-zero on error. Split that, just this one change. Okay, and then the rest of it is set up a convert to a daemon. So That includes the path, creating the path, setting up the daemon, and changing the startup function. So there we go. Now this thing is a daemon, so that's good. Next up is to actually make sure that it starts up on boot, which it obviously currently doesn't. For that, we need the systemd unit, and we need to have the systemd unit also be enabled. Know that this is a background thing, and it will need to run very early on, because it very soon will be configuring the network, so it needs to run kind of prior to anything else. Let's see, I don't think I already have any systemd units in the extra folder here. Let's look. Images, base, so this would be to macOS extra that we would then do lib systemd. Actually, I think the incus-OS, the incus agent stuff are in there. Yeah, incus agent is there. Cool. So let's just use that as a template, because I never remember the exact syntax for that stuff anyways. And we'll just do incus-osd service, and then go and edit that a bunch. So incus-OS management daemon documentation. Well, we don't really have much of that going on yet, but let's just do incus-OS, and it needs to be run before. I mean, cloud init is not a thing, so we don't care. But before the multi-user target, that seems like a good idea. Like for now, we'll probably leave it like that. In practice, so I mean, currently we're actually cheat. We're gonna do after systemd network the service, or network online actually. What's the name of the network online again? Let me systemctl cat incus. So incus is after network online target and requires network online target. So let's do that. That's not the correct condition, because as soon as we merge the network support, we're gonna need to run earlier than that. But for the time being, since we don't manage network and network is configured for us, we need to run after it's in place. So that's where that comes in. For the rest, we can kind of take it from part of the incus stuff. I think that's going to be more accurate than what we're looking at here. Don't care about environment, don't care about defaults. Exec start is simply user local bin incus-osd. If we get killed, the process should go away, not any of the other processes. That's fine. Timeout, we should just give it 30 seconds. Restart on failure, yeah. Delegate doesn't make sense. We don't need to mess with the allocations either. So that's about right. Now I need to have the install section. I never remember the syntax for that either. Oh yeah, there we go. It's just wanted by multi-user target. So let's put that. And that should be it, I think. So let's see if that works, I guess. I'm gonna go and build an actual image, which takes a bit longer these days. As mentioned, I've added ZFS. So ZFS is a bit of a beast. My desktop is also not the fastest thing ever. So when you do get to building the kernel modules for ZFS, that takes a minute or two. But yeah, hopefully this works. And then on startup, so what I expect to see is that on startup, it will run it will automatically run incus-osd, which will fail to find anything to install, because out of the box we don't have any application present on the file system, and that's the development mode. So in development mode, we can't go on GitHub and download them from there because they're not correctly signed. So we need to use the make test applications target to push the applications in. And normally the way we're doing it was start the VM,
do test applications to push the applications in, and then that would then run incus-osd for the first time, that then installs the applications. That won't work anymore because now incus-osd is already running. So instead, what we'll have to do in the make file is if you do test applications, it should push the applications in, and then we can either reboot the VM, which is one way to get things to reapply, or we can just ask systemd to just restart that. So that should work pretty well. So effectively, yeah, we're probably going to go with the restart approach. That means when we do make test applications, we do the same thing, create the folder inside of the environment, push the applications in, push the release version in, and then just restart the daemon, and it's gonna do its thing. Same thing for updates. We can do the exact same thing. Push the new updated version, restart the daemon, it will pick it up, and then it will apply the update and restart. That should be fine for the development environment. For production, that shouldn't be a problem, because in the production case, it will actually be able to reach out to the internet and fetch any update, any applications directly on first boot. So anyway, this is now running just fine. The other thing I was trying to remember is like I need to tweak the seed handling so we only read it on the first time, because we store a state. So if we go look at valid incus-os, where is it, state, we do have the list of applications that were deployed that way. So if we don't find the seed on the first start, then the application list that we need to look at should actually be pulled always from the state instead of from the seed. So let's see if we can do that real quick while the image is building. Wrong repo, wrong code base, wrong everything on this one. So let's just switch back and then go look at incus-osd command package main. Okay. So currently the way it works is on startup, we're trying to pull, so we've got a default to install, then we're trying to pull directly from the seed, and then we get list of applications, then we create persistent path and all that stuff. That needs to probably change a bit. We should first try to locate our state, and then what to install. So what we do here then is if so I don't remember, let me just check out the state in the loader create. I think it always returns a map. It's just potentially empty. Yeah, I think it is. So what we should probably do is if len the of s.applications is 0, first start, in which case we can go and load stuff from the seed. Like that. Otherwise, what we do is we instead go and iterate through the existing application list. Like so. We have an existing application list, and instead of iterating over apps.applications, we're iterating over the state, so s.applications, with otherwise the rest being mostly the same. Let's see if that wants to build. Does not. 82. Yeah, so this one needs to be changed there. No field or method name on state.application. Okay, let's go see what the state looks like now. I don't remember that structure exactly. State file struct. Okay. State applications. That should be fine. There's a map,
and map gets us the version. Oh, okay, yeah, it's a map name to version, name to application, instead of having a name property. Okay, so that just means that this is the name, and we don't actually care about the app. We just grab the name. So that changed the wrong one, didn't I? Yeah. So let me change the correct one instead. So this is the name. Don't care about the app. And grab the name. Yeah. Okay, so that built fine. Also, the base image finished building, so that's cool. Now let's try that new image. So let's do test from here, I guess. Make test. So that's gonna blow away the current VM I had and just redeploy it. And with a bit of luck, when this one boots up, we're gonna see incus-osd being running. Yeah, there's always a bit of a race that I lose occasionally on the console side. Okay, let it boot up. It's doing the initial resize. Here we go, repartitioning. And we're running. I saw an incus-osd in the log, so let's see. Failed. Incus-osd failed to start. Okay. Why? Okay, it failed because it was trying to look up the look up any updates on the system. So that failed because the path doesn't exist. That needs to probably be fixed. So it's in the incus-osd internal providers local, provider local, where we show here updates, check release, but then check release would fail here because the path doesn't exist. So where's the best place to just handle that? It probably makes sense for loads to fail with an error saying like provider unavailable or something along those lines. So let's try that. Deal with missing off. We usually have a util package in Incus that does that. What's the correct way to do a path exist thing these days? Okay, it's just an else start on the thing, and then we check if it's not exist. Okay, that makes sense. Cool. Let's do that. So else start of path if it's not null, and then we'll do a special case of if OS is not exists. But I think we're doing something different here. Yeah, it's the newer form with errors.is, so I should probably do that. Fine, let's do the newer syntax like that. And in this scenario, we want to return provider not ready, something along those lines. Let's see, did we have any other errors defined in there? Doesn't look like, no. Okay. we can define it here, I guess, but probably makes more sense as a generic package file in there. So package here would be what is it? Providers, I think is the package, and then var provider not ready. New error. Provider isn't currently available. Should I probably do provider unavailable like that? This needs an import for errors. There we go, and then change this one for provider unavailable. Did I typo that? Doesn't look like. Good. And put a comment on this one. Typo in the last file. Not sure which one. Which file was it? Provider and if it's a typo in unavailable because I typed it 5 times, it's probably gonna yell at me. Yay! So it was line 30. Oh yeah. Good catch. Thanks. Alright, so we need fs loaded, and which one was it? 37. Oh yeah, defining error again, and importing fs in this one. Cool. What? Okay, what's... Oh, it's io/fs for fs, okay. There we go. Okay, so that builds fine now, which means incus-osd main, when it loads the provider, those can return errors, obviously. Now we're gonna get the unavailable error. Oh, actually, it's gonna yell at me for another thing. I keep putting capitals in errors, which is not Ghost preference these days, so I should fix that. There we go. So this is gonna be returning an error. Okay, error is it's shared, so we can actually tweak that. I don't really like doing that syntax very much, but we can actually do it in this case, which is then that gets the update. So if we don't have a provider, we can basically skip all of that and go straight out. Okay, so let's actually do that. It's gonna be cleaner. So if errors.is error provider unavailable, then we should just finish running here. Just put a comment there. If provider is unavailable, we are done with startup tasks. So we do that one here, and we'll do the same one in the dev environment here. Okay. It's complaining about a couple of things. So provider local line 28 or so. Yeah, makes sense. Should omit second value from range. This loop is equivalent. Oh yeah. Let's do that one. incus-d at 118. We don't need to do that. Okay. And a formatting thing. So Static analysis, are we clean? We are, nice. Okay, so now incus-osd, looking at the changes. So the first change is to only apply from the seed on first start. So that's one thing that can be committed on its own. incus-osd only read seed on initial start. It's not the most solid logic. I'm probably gonna tweak that a bit so that we have an actual reliable way from the load or create function to know whether this is a first start or not. That's gonna be cleaner than this mess, but that will do for now. And then the rest is about handling handle unavailable providers. So let's do that. Okay. Now that we've got that stuff done, let's go and make another image. Actually, we can kind of test it still the way it is. So if I modify makefile for test applications here, so we can see we're pushing everything. And then at the end, we run incus-osd. So we don't need to do that. So we don't need to push incus-osd anymore. And instead of doing this here, we just need to systemctl restart incus-osd. So now if I do test applications, and let's look at the journal here, because that's going to be the most useful part, I think. It creates the files, pushes things in, incus, debug, restarts OSD, and initializes. There we go. And we should have incus. Yep. Got incus, and let's look at the systemd state. It seems quite happy with incus-osd. Yep. Okay, so that's looking good. Now what we're gonna do is build a new image with the fixed OSD. And while that's running, I'm gonna go update the other makefile target for updates to also do the right thing. So paste update. Same thing, no need to push incus-osd anymore. Just needs to figure out the current release, make sure the paths exist, push all of the artifacts into place, and then run a restart for incus-osd. Okay. So once that image is built, then we should be able to do a make test update, which will push that new image in, and then kicks incus-osd into applying the update, which will then cause a system reboot. Then once the system is rebooted, what we can try is wipe out the update folder from /root and restart incus-osd and see if it actually does the right thing at that point, which would mean just starting up, no errors, just because the provider is not available. Actually, one thing we should change for future run is logging something in that situation instead of just silently dealing with the provider not being available. We should use like slog info or something. So we've got a logger here, so it's the logger. Okay, so an info message there. And so if we're unavailable, we should probably do like a warning or something. Update provider, insert name. Well, yeah, it should actually, yeah. We don't have a provider. Okay, why are we doing that actually? I'm just looking at like what we actually need in here is to figure out the provider name, and then we can use the rest of the logic and kind of fold that stuff. So let's just do that.
instead of this entire stuff. So just do var provider string. This is provider GitHub. This entire logic here can go away, goes back down here now. And then in dev mode, provider is gonna be local, like that. That simplifies things a bit. And then we actually load the provider by its name. So, were we passing any data to the provider? No, we are passing null in both cases, so that doesn't matter. Okay, update provider, now we can use its name, is currently unavailable. Okay. Oh, actually, no, slog doesn't like that format, it prefers that format. So anyway, we'll do it that way. Oops. Okay, so that will log pretty clearly that the provider was unavailable at that point. So let's do that. Okay, makes sense. That was a variable earlier, it's not anymore, so we just need to fix that. Keep using the wrong command. At some point I'll get it right. Make incus-osd. Okay. Oh, and the image is done building. So let's do a make test update and see what happens. So that pushes the update into the VM. There we go, incus debug, it restarts incus-osd, which didn't really do anything because it, oh no, never mind. I was gonna say, because otherwise it should kick me out, like as soon as the update is being applied, but yeah, I did do that, just took a tiny bit longer than I expected. So that's good. We were running on 2025-03-13-18-10, and we should be running on something on 1829 is what we should be coming back up with. Okay. Last run detected 1829. Yep, we're good. And now if I wipe the update folder and I restart incus-osd, does it fail? No, it's happy, starting up. Yeah, that should be fine. I don't love the fact that it's not enabling the services. We might need to do a tiny bit of different logic actually, but it's pretty good. So that's the new provider logic. So let's do incus-osd simplify provider loading. I did actually check if there's any static analysis that I messed up by doing that. I did. Okay. Guess was the main 171. Okay. So that's fine. And yeah, I wanted to see what I can do to still run the post-update stages effectively. So we've got the update, the OS update stage, application update install, all that kind of stuff. But then afterwards, we've got refreshing user, starting incus. Those pieces should still run. So that's kind of where we can switch a bunch of that stuff to I guess an update, just an update function for now, sort of having any better name for it really. Context, and then we want to pass in a, what does it need? Probably needs the state in the provider actually. So state, and P is the provider, so provider, something along those lines, returns an error. And that's why we need to do things slightly differently, because if it's so yeah, anyway, I'll change that object in just a bit. That's the new function. So now close that, and then from this function I want to pull that bit out, move that up to here. And we should need to actually make the Incus startup conditional on Incus being installed. I don't know why that hasn't been done already, actually. So we'll just do OK, state applications and Incus. And if we have Incus installed, then start it up. Otherwise, no need. That will probably change too. It would make sense for the applications to have like a startup function or something along those lines, so I don't need to hard code Incus in there, but for now that will do. And the missing piece here is basically if so if not this, then we want to return the error. If the provider is unavailable, then we want to know about it, but not fail. Just the detail. Let's just put the message that provider is currently unavailable, and then the actual call to the update function should only be run in this situation. Run update function if we have a working provider. In this case, we want update and we want to pass context and we want to pass the state and the provider. And then handle errors on that thing. All right. Something along those lines. Let's see what my chances are that this thing actually builds. Okay, not as bad as it could be. I think it's probably providers.provider. Yeah, looks like it. Cannot use as parameter. Okay. Oh, it's an interface, right? So it's not a pointer then. Okay. Then it needs running release and to install. Okay. That's because some of the logic was kind of split out. But this can go into update, because if we don't have a provider, none of that stuff matters anyways. And the running release, that might also be, I think we only use it during the update. How we, what do we use running release? Let's see. I think it's in one of the log messages, maybe. Yeah, it's in the starting up message. Okay. Kind of feels like it should belong into the state. What else do we have in state? Yeah, it feels like we should just have a running release field in here. And we won't, so the state is saved to disk, but we won't actually persist that one, I guess. Actually, we might. That might be useful just to know next time we boot, it will give us the last one we've used. So we can do that. We'll just dump it into the state file as running release. Okay. Which then means here we can go with, we get the running release, but then we dump it into the state.
like that. And then anywhere else we use running release from that point on, we should just pull it from the state instead. Okay. Good. And then next up is the to install stuff. As mentioned, none of that stuff really needs to be in the startup function. It only is relevant to when an update is run, so it needs to go into the update function instead. Like that. Yay, so that builds. Now static analysis, because I reshuffled a bunch of stuff, so it's probably gonna be mad at me. It is. Yeah, I disagree with that particular check. It wants me to use camel case in JSON, which is not really a standard JSON. It's usually snake case, even if Go really likes its snake case. So let me check. There might be a way to turn off that particular checker just for JSON somehow. Yeah, you can actually override it, looks like, and telling it to use a different style. So let's see. Linter settings. It was Tagliatelle, I think was the name of the thing. Yeah. And then linter settings. Okay, I'm just trying to figure out in the help what that looks like. So it looks like it's maybe case, rules, and JSON snake. Let's try that. Yay, okay. All right, so that's all good. I guess we can build one last image, update to that, and just see how it looks. While that's building, I'm just gonna commit all of the changes that have been made. So it's only in this folder we really care about. Use snake case for JSON files. That. And then there's a bunch of extra logic. So we'll start with incus-osd, add running release to state. Actually, let's look at all of the changes, see what makes sense. So that one, not this massive change. This one, nope, yes. Okay. And then the remaining logic is incus-osd, split update logic to on function. Oh, it looks like I missed a extra file earlier. Let me just merge that one in. Okay. So that provider here actually made sense to put handle unavailable providers there. That's where it should be. Just waiting for ZFS to be done building. And then we should get an image up and running. But assuming we're still clean. Oh, actually, I forgot to also commit the addition of the incus-osd service, so we need to do that. Base include incus-osd service. there. Okay, so that's the new set of changes. Let's push that to my branch on GitHub and prepare the pull request while the image finishes building. So let's compare incus-OS changes there. Make incus-OSD a daemon. That's the main piece of work. The rest is kind of all related to that in one way or another. So here we go. And that triggers a bunch of tests, like actually running end-to-end building, CI, static analysis, all that kind of stuff. So that's going to take a little while for the pull request to go through. Not sure why the tests haven't started yet. Seems like GitHub might be a bit slow today. That's been known to happen. So anyway, just waiting for the image to be done building. And if that all behaves, what I'll do is I'm gonna push a new tag to the branch once my pull request has been merged. And that will give us a new clean image on GitHub releases that we can then pull and run. I think the scripts will also need updating at that point. We've got scripts to actually download and update images and stuff from GitHub. That's gonna need a bit of tweaking, I think. But anyway, image is done building. So let's trigger an update. If we look at what's going on with the incus-OS daemon, actually we can look at the system overall. Let's do that instead. Okay, test update. So it's gonna push that update again to our test VM and then kick incus-osd so that it processes the update. There we go. Downloading OS update, it's unpacking it and applying, which should then take a few seconds, and we're rebooting into it. Once we're back, it's just gonna be like checking what the log looks like on boot, and if it makes sense, then try to remove the update folder, restart the daemon, make sure the behavior looks good. All right, so incus-osd since boot. Found the keyring, starting up mode dev, system already up to date, downloading system extension incus, refreshing, applying. Okay, so now we're good. If we do a restart on it, the restart shows everything is already up to date, so it didn't touch incus. That's what we expect. And now if we wipe the updates folder and restart, restart, what does it do? Okay, and we should have, yeah, warning, update provider is currently unavailable, refresh user starting incus. So exactly as expected, so that's looking good. And as I said, like the only kind of pieces remaining would be on the script side. Also, did GitHub actually start testing? Yeah, it did, good, took a while. So on the script side, we've got two, we've got spawn image, update image. Update image doesn't make sense anymore since we auto update anyways, so that's gonna go away completely. And then spawn image goes on through GitHub and downloads a bunch of stuff, including the applications. That's also not needed. Imports into Incus, that's fine. Create incus-OS instance, DPM, all that stuff is good. And then waiting for instance to boot, that's fine. And after that, we've got loading the packages and all that stuff. None of that is required anymore, so we can remove that. Okay. So scripts update for incus-osd, basically. So that's removes all that stuff. One trick that would be nice to add, but I'll probably do that later, is having spawn image take a comma separated list of applications we want, and effectively generates the seed and load that into the image automatically. So that would be good, but not needed just now. All right, I think that's gonna be it for today. Let me actually check something else. We've got two workflows that are run, one for during build time. So that's when the tag is made, which builds the actual image and then downloads all the artifacts. I think that doesn't need any changes. And the test one, let's see if it needs any change. So test one, that's just code tests, and then we've got end-to-end. So for end-to-end, we install the dependency, set up Incus, make OSI, build an image, start it into incus-os, wait for it to be available, check the image, okay. Then incus-osd environment, what does that do? So it gets the release, pushes things into place, okay, that's fine. So that pushes, okay, it pushes incus-osd itself, that's not needed, we can remove that. But those stages are otherwise fine. Then for the extensions, it pushes them in and then runs incus-osd. That's wrong. These days, it's restart incus-osd like that. So that's gonna apply those applications. The point is that it's not blocking. So now we need to actually put a delay. That's gonna go away once we actually have an API that we can talk to, but right now we don't. So putting a delay instead, at which point Incus should be operational. After that, we build a new image, that's fine. Get the new release, pushing the release into place, and then once again, we need to go and systemctl restart incus-osd. That will succeed. Then probably sleep 30 seconds, incus-exec test incus-os, and we'll cat the release file. So it's user lib os release, I think. Is that right? Yeah. And can probably do actually grep image version in user lib os release. Yeah, that will give us what we want. That way we can make sure that it actually did update on the correct thing. So that gives it 30 seconds to apply the update, reboot, and be back online, which should be realistic. So let's update GitHub, update for incus-osd, and push that. And that should be it. So that's the final set of changes available. It failed during the previous run. Let's see where it failed. Like, we've just, pushed a few fixes there, so that makes sense. It failed at, oh, strip is not installed. Oh, that's unfortunate. What's the package for strip? Bin utils. Okay, so we need bin utils as well in both test and build. Okay. All right, what's it doing now? I usually need to wait for it to start doing the actual run. Otherwise, we end up with a self-hosted runner that's just kind of stuck running forever. So that's never really ideal. So for that reason, I usually just wait for that job to actually start. Then I can push again and it gets canceled and properly releases the runner. It doesn't take super long for the runner to start going usually. So that should be fine. It should take another few seconds, I guess. Actually, kind of surprised it's not running yet. Let's see. Okay, it shows it's running. I guess it just is still installing some dependencies and hasn't connected to GitHub yet. Oh, there we go. Now it's running. Okay, so since it's running, can git push this one. That's gonna cancel the runner and do another clean run with binutils this time around. And that's gonna be it for this live stream. Thanks everyone for following this work. I think this one was a reasonably busy one. Converting incus-OS the OSD to an actual daemon, that was pretty trivial. But then there was a good opportunity to tweak a bunch of the logic to kind of tidy things up, make it handle missing providers, make it like skip steps in the right situation. I think that was pretty useful to kind of tidy up a lot of different pieces. And also now making it so that on GitHub, the notable release will effectively use incus-osd. So if it gets started into a VM, it will just automatically pull update its packages and just set itself up and be operational. I'm really looking forward to Matthias completing the work on the configuration generation piece, because once we've got that one landed, then we'll get to do a bit more with the seed logic. So the idea is that like if nothing is provided through the seed, we'll just do DHCP on whatever network interface we can find. If you provide a seed, a network seed file, then we can do bonding, bridging, all that kind of stuff automatically, which would be pretty neat. So that part hopefully will get in the next few days. And then the next piece for Matthias to look at is going to be on the storage side, specifically how to actually do an installation. Because currently incus-OS, as you've seen it, is effectively a pre-made disk image that expands on first boot. But most people can't really do that. They instead have a machine that needs to boot from a USB stick and then gets installed. So we need to implement that, which basically means a bit more YAML seed data, which gets read and will effectively say, okay, please wipe and install onto this target disk. And instead of going to update itself and install all the packages and everything, incus-osd will just right at the beginning copy the files, copy the main partitions across to the target disk, then reset itself and reboot, at which point it should boot back on the actual disk, not the USB stick, and then proceed with the actual normal update, self-update and package installation at that stage. So that's the idea. That's kind of what's next on our side. There's a lot more to also build up on top of the API, so I might look at doing that next week. Effectively starting to put REST API endpoints and doing some of the plumbing so that when Incus starts up, it detects incus-osd and then provides the incus-osd API through the Incus API itself so that a remote client can interact with the incus-OS API through Incus. So that's kind of what's coming up. A lot of different pieces are kind of all falling into place. We're getting very close to supporting installation, supporting networking, and supporting configuration of Incus, which is really what's needed for most folks to be able to use this thing. Like as far as storage support, we're good now. We've got ZFS in, which is the main thing we wanted for local storage. And then on the network side, we've got Open vSwitch in, and I'm pretty close to also adding the Oven controller, which would then let us have a system join an existing cluster with Oven in place. So making some very good progress, definitely getting there, and it's nice to see everything falling into place, everything looking pretty clean, and in general the code base being quite small for just how big of a thing we have. Like it's literally an entire OS image, and it's just a few text files in a GitHub repository. So it's really nice to work with. All right, hopefully it was useful for everyone. I'll see you in the next one. Also on GitHub, on YouTube, yesterday we published a overview of the Migration Manager project that my team at Future Fusion has been working on for the past few months. So if you've got any interest in moving from a VMware environment to Incus, maybe take a look at that. One thing I didn't mention in the video, because we didn't test it at that point, was even though all of our testing has been done with larger VMware cluster using vSphere and all that stuff,
you can actually use Migration Manager just fine, even with a standalone ESXi. So if you're running a home lab and you've got ESXi in place and you want to get out of ESX, you can use Migration Manager to move from that over to Incus. So just something to be aware of. Also, plenty of issues and stuff open there. So if anyone has some spare time, wants to get their hands dirty, contributing to a Go project, we've got plenty of things to look at over there. Thanks a lot for watching this one. See you in the next video. Bye.